Hi, welcome to Domain 3 of CCSP exam. This domain is as well split it into two parts, and this tutorial is focused on part 1. Please subscribe to the channel and enable bell icon if not yet done. We are going to focus on the cloud infrastructure components. So these are the components that we have as part of the cloud infrastructure, which makes the cloud more successful, starting from the physical environment to the management plane. We have many components involved there. If we talk about the physical environment, this really talks about that the physical access, authorization, and control that defines and enforces the controls for the least privileged access to the physical resources, and access control for the transmission medium, like define these security safeguards for power and network cables to prevent damage, disruption, tampering, or even theft. Physical access monitoring, this is where we develop the capabilities to investigate and respond to the physical security incidents. Monitoring can also can include things like physical access logs and security cameras that monitor the data center ingress and egress points. Similarly, we have emergency power, um, because if we have power down, then the critical or the services goes down and becomes unavailable, cannot be available to the customer. Fire and water damage protection, we need to take care of the fire and the water damage to the data center. Asset monitoring and tracking, cloud provider must keep track of each and every server and the other hardware components, and also ensure that they remains in the authorized locations. Data center location, it is also important aspect that we need to consider from the security point of view. Sufficient and redundant power supplies and cooling for the data center, sufficient redundant network bandwidth. We need to keep the redundancy. We need to maintain the redundancy for the data center. So then we have the virtualization capabilities, risks, and challenges here. The virtualization is the process of creating the software instance of the actual hardware, and this is the vital component of the cloud infrastructure, because without virtualization, it is not possible to achieve really the cloud computing. It increases the scalability. Virtualized environment are designed to grow as your demand grows. Instead of buying a new hardware, you simply spin up the additional virtual machines or virtual instances and do your work. Allows the faster resource provisioning. So as much as we have the virtual environment, we have virtual instances, it is more faster to provision our resources much quicker and faster way, without wasting any time. Reduce downtime, we don't need to reduce the downtime. Restoring or redeploying the physical hardware takes a lot of time, especially at scale. Failover for the virtual resources can happen much more quickly, which means your systems remains up and running longer time. Avoid vendor lock-in. Virtualization that abstracts the software from hardware, meaning your virtualized resources are more portable than their physical counterparts. If you are not happy with your vendor, just pack up your VMs and move to the another one. Saves time and money. Of course, the virtualized resources can easily and centrally managed, reducing the need for the personnel and equipment to maintain your infrastructure. And in addition, the less hardware usually means the less money. We have this there are two types of the hypervisor, type 1 and type 2. When we talk about the type 1, in type 1 we have bare metal server, which is more having the hypervisor directly installed on top of it, and then we have the virtualized resources running on top of the hypervisor. While in the type 2 hypervisor, we have bare metal physical host, which is hosting, the another host OS, and then we have the hypervisor on top of the host OS, and then we can run the all virtual resources on top of that. Multiple VMs we can run here. The primary difference in type 1 hypervisor and type 2 is that the type 1 is known as more hardened. It is not exposed, highly exposed, but the type 2 hypervisor is most exposed and more prone to the attacks, unless it is hardened and implemented the mitigation plan for that. Risk and challenges. We have certain risks and challenges for the hypervisor security, because security flaws in the hypervisor can lead to the malicious software targeting individual VMs running on it. Flawed hypervisor can facilitate the internet inter VM attacks. For example, the VM hopping when VM isolation has not been configured properly. So just ensure that we have VM hopping, mitigated properly after implementing the VM isolation properly. There, network traffic between the VM is not visible, which means the additional control is needed. Also, the resource availability for the VMs, which can be flawed. VM can be starved of the resources. You have multiple resources running here, and if one VM is attacked, and it can consume all of the resources of that server, and the other VMs will continue to starve of the resources. The VM and their disk images are files residing somewhere else. So a stopped VM can accessible by the third party if no proper controls are applied there. So these are the kind of risks and challenges in the virtual environment. Compute, networking, and storage. These are the another component in the cloud infrastructure. So compute is where the resource takes data, process it, and show you the output of that processing. Just like in the traditional data center models, where the cloud-based computing comes down to the compute, CPU, and RAM capabilities, like reserved resources per guest OS and per host basis. This is to achieve the guarantee for minimum resources. Networking, managing the physical network, is completely the responsibility of CSP, the cloud service provider, and every CCSP professionals should understand some key functionalities in the cloud network. Routing, just like the routing, filtering, rate limiting, address allocation, bandwidth allocation, and then we have the software defined network, which is in the virtual environment. To achieve the virtual networking, it is very important to understand the SDN from exam point of view. It is approach to network management that enables a network to be centrally controlled or programmed, providing the consistent and holistic management across the various application and technologies. So it has the three different layers. One is the data layer, also known as the application layer. Control layer, this is also known as the control plane. Then we have infrastructure layer. It is also known as the data plane here. So data, while we talk about the control layer, this is basically the control plane implementing actual SDN control logic, and everything happens here in the control layer. The SDN logically optimizes the network traffic, receives the service request from the application layer, and is responsible to provide the configuration and forwarding the direction to the network forwarding equipment in the infrastructure layer. When we talk about the infrastructure layer, or more of the data plane, by virtualization your entire network infrastructure, you increase your attack footprint and give attackers a central target, the SDN controller, that could be used to compromise your entire network. Pay special attention to secure the SDN controller through the robust access policies, system hardening, and encrypted communication. Storage, we have two types of storage here. One is the volume storage, and another is the object storage. The volume is for the traditional, block storage, and is used when the cloud storage is allocated to a VM and used as if it were a regular hard drive attached to that machine. While the object storage is the file storage that is attached to any of the particular VM or any application, and is kept on a separate system that is accessed through APIs or web interface. For example, AWS S3 bucket, that is more object storage. Then we have the management plane, allows admins to manage any or all of the hosts remotely. It is used by the privileged users who install and remove the hardware, software, firmware. The primary interface is API to use the management plane, because API, with the help of APIs, you can automate all the provisioning, deprovisioning of the resources, the authentication part, start stop of your VM instances, creation of the VM instances, and access control. So all of these things can be achieved with the help of the APIs. Here, it is the most powerful tool. It integrates the authentication, access control, and logging monitoring of the resources used. If the management plane is compromised, it can bring down the whole infrastructure. It is important to harden the management plane and control the accesses there. This is very important point from the exam point of view. Just remember that this is, if it is hacked, then it can, it can bring down the whole infrastructure, and it is important to harden the management plane and control the access on the management plane. Then we have the secure data center topic. So what is important to secure to when we design a secure data center? So first of all, its location. When it comes to the location, what it means, basically the geographical features of the area. Tall trees, for example, are a wonderful and free barrier, when we decide for the data center location. Risk of the natural disasters and the weather events to consider of that area, geopolitical risks. For example, it's worth noting, if you are building in a war zone, for example, you need to reconsider that location, right? Because you cannot invest too much money building the data center there, where you identify that as a war zone. Access to and cost of the telecommunication infrastructure, that is also the consideration point while deciding the location. Availability of the utilities and the other essential resources, labor cost and availability, and what it requires for the secure building, the material and thickness of the building's wall, that is important. Number of ingress and egress points, the entrance, exits, we need to consider. Type of parameter fencing, what kind of fencing is there to protect from any trespassers or any attackers. Type of locks and alarms that on the external and internal doors that is used. Redundant electrical and the telecommunication suppliers that we need to consider while designing the secure data center and considering the secure building. Physical security monitoring, only authorized access to the critical area. Visitors should be verified, should be logged, monitored around the clock. Security patrols, and we should have some security guards to respond to any intrusion, to decide. There has to be some kind of decision making as well. Environmental design, when we consider this, for example, the temperature, because if you have four computers inside a small room, you can imagine the kind of temperature that it builds up. And when we discuss about the data center, the cloud data center, especially where we have thousands of the servers running, which are running with the multiple virtual instances and containers and different workloads running on those, you can imagine the temperature that will be shoot up on these machines. Next is the humidity. It is important aspect for any electronics. Humidity is the water in the air, and water is bad for any electronics. So humidity should be monitored and controlled within the data center, with 50 to 60% being typically recommended range for the data centers. Electrical monitoring: a secure data center should be designed to monitor the electrical levels, to not only trigger the backup generator using outages, but also to watch for the energy spikes that can damage the sensitive equipments. Fire suppression: the systems are in absolute must in the data center. Um, and not only do they keep the data center personnel safe, but they are pivotal in the preventing the widespread outages and data loss should a fire occur. Hopefully you never need them, but we always need such equipments or the tools, for fire suppression systems inside the data centers or around that. um, Better safe than sorry. So this is very important to consider the fire suppression equipments and tools. Risks associated with the cloud infrastructure. So in addition to the virtualization risks we discussed in the previous slides, we have more cloud specific risks in these categories, like organizational risks, which are more related to the policies, reduce the visibility and control, um, staffing and operational challenge, vendor lock-in, financial management, the high cost in switching between the providers. If you decide, okay, I have to switch to the another vendor, but you have some dependency, you cannot. So these are the risk: loss of governance, consumer not implementing all the controls. That is another the risk for the loss of governance. Compliance risks: specific cloud service provider may not be compliant with all regulations like HIPAA, PCI, and depending on your service model, you need to work with your cloud service provider, and you need to decide who is responsible to comply with those regulations. Provide exit providers by exit bankruptcy of the CSP. The cloud service provider is bankrupted. Now what to do? So this is another risk. Compliance and legal risk: where does that regulated data reside? Who accesses the data? How is that data, regulated data, protected? So from the data protection perspective, the protection of PII and the other sensitive data by cloud service provider is essential if they are offering you software as a service, and you can consider similarly the responsibilities based on the service model. Jurisdiction: the data storage in the multiple location and in multiple jurisdictions, which can affect the risk and control. Law enforcement, licensing. So these are all kind of risks that we have and associated with the cloud infrastructure. Cloud vulnerabilities, threats, and the attacks. The cloud environment at a high level experience the same type of threats and vulnerabilities as on-premise infrastructure. Here, the cloud infrastructure, cloud environment runs the application. Those applications have vulnerabilities, and bad guys try to exploit those vulnerabilities to compromise the systems and the data. But when it comes to the management plane, to compromise that, the most valuable attack target and the highest source of risk in the cloud environment, because if it is compromised, then it is highly likely that you will lose everything almost, because management plane are made available to the customers through the internet facing APIs. They are widely exposed to the attackers for exploitation. Malicious actors look for weak APIs and can exploit the vulnerabilities to gain access to the organization's cloud system and data. The cloud service providers here are responsible for securing their APIs, actually. Then we have insecure data commissioning, data decommissioning. So when it comes to the data deletion and the sanitization, that can leave the portion of customers' data available and potentially exposed to the other CSP tenants who share the same infrastructure. So this potential data leakage is particularly concerning for the customers managing the sensitive information like PII, PHI, and cardholders data. Instead, the customers rely on service level agreements, contracts, and data agreements in which the cloud service provider commits to certain processes and the timelines for the secure data deletion. That is important. Insecure multi-tenancy, without multi-tenancy, the cloud is incomplete. Of course, at least the public cloud, because the multiple tenants are sharing the same server, where we need to implement the isolation controls to segregate logically and physically. Without proper separation between the cloud tenants, and attacker can leverage one tenant's resources to compromise the another tenant's environment. Resource exhaustion: if one VM is attacked, then that can be misused to exhaust all the resources on that particular server, because that server is being used by the multiple tenants. And if one VM is hacked, then all the other machines will get impacted. Network host and application vulnerabilities: as with any computing system, the cloud environment are made up of the hardware, software that may contain security vulnerabilities. In terms of the cloud infrastructure, the cloud service providers are responsible for routine scanning and patching of the host, network devices, database, and the applications under their control. Virtualization risks: we have architectural risk and hypervisor software risk, and the configuration risks here. Lack of visibility into the control over the virtual networks. This is where the virtualized traffic is not easily monitored with the existing physical network monitoring tools. Resource exhaustion, that we just discussed, the workloads of the different trust level on the same host. This risk is due to the multiple multi-tenancy and the resource pooling. If the sensitive data that is shared shares the resources with less sensitive information, appropriate controls must exist to separate and appropriately categorize and secure each classification of the data. Risk due to the CSP APIs. Uh, this is again because these APIs are highly exposed and available directly on the internet, internet facing APIs, and highly exposed to the attacker. So it is important, and are risky as well. Hypervisor software risks: if not managed, the hypervisor security risk, especially if not managed throughout its tenure, entire life cycle, the hypervisor may contain exploitable vulnerabilities, especially unauthorized access to the hypervisor, because it's the holy grail of the virtualization. The weak access control mechanism that present immense risk to the cloud customer and their data. Also, the account or the service hijacking through the management portal. Configuration risks: we have VM sprawls. What is VM sprawl? Is where we increase the number of VMs on a particular servers that becomes unmanageable for the cloud administrator, and can no longer effectively be secured, and because they are not able to manage them. Sensitive data within a VM, because VMs are just files and can be moved from one place to another. Lack of strong security controls like encryption and security control or access control poses risk to any sensitive data contained within the VM. Countermeasures strategy: we have access control, prevention and detection control, and then automation. It is important that you develop and employ the countermeasure strategy that are based on the defense in depth approach to combat with risks. Your strategy should include logical, physical, environmental protections, and layered controls. For example, the physical protection of your data center should include reinforced walls, strong locks, video cameras, security guards, and a tall perimeter. Among those controls, your countermeasure strategy should be to use not only the preventive controls but also the detective measures, and just detect and prevent, try to prevent that in the first place. And automation is another one where we have to consider the automation as a strong countermeasure, because when we identify the vulnerability in the system, then it helps us to implement that faster way and deploy the patches faster way. So automate is the only key to be successfully implement the countermeasures for the cloud strategy. With this, I conclude the first part of CCSP Domain 3 tutorial. Thanks for watching. I hope you like the content in this tutorial. Please tell me in the comment section. Your colleagues may also need this, so just share the link with them as well. Please like, comment, share, and subscribe to the channel for regular video updates. Thank you.